In this video, I want to walk you through my brainstorming process and using AI to come up with ideas and plan the app that we're going to put together. Of course, this video will focus on brainstorming a BIM-specific app, but the principles could be applied to any app out there. So let's get into it. You'll see here that I'm in Google Gemini. You could use any AI tool you have at your disposal. OpenAI's ChatGPT, you could use Perplexity and any other number of tools out there. Specifically, what I like about Gemini, Claude, and OpenAI is that they have this canvas mode, as you can see here. They call it different things, but essentially you can generate documents and iteratively work on those documents. And as you'll see in a little bit, we can even push it further and create a UI mockup that we can then give feedback to, and based on that feedback, integrate it back into our app specification. So let's go through what I put together here. I started off with a fairly simple prompt. I said, I want you to help me brainstorm something. Essentially, I want to build a pipeline for building information modeling so that I can ingest an IFC file. I gave it a summary of what we discussed in the first video, and I even fed it that video. So then it went through, it gave me some feedback. And the key here is that we're not just letting AI do whatever it wants. We're going to be guiding AI to do what we want. I read through this, and pretty quickly I noticed a couple of things that I didn't agree with right at the beginning. I said, for now, I want the initial trigger to be an IFC file is uploaded, dragged and dropped into a web page. This web page has no authentication. It simply treats each newly uploaded IFC file with a unique URL. What I'm trying to develop right now is a specification that will give us a minimum viable product for that idea of a CI/CD pipeline for our BIM models. So in a minimum viable product, we do want to keep things as simple as possible so that we can test our end-to-end application quickly and iterate on it from there. Then it came back with a much better description, but it was still talking about a backend server that's going to receive files and stuff. So here's where some domain knowledge comes in handy. Now you can approach this different ways. In my case, I am up to speed somewhat on what that open company has been doing with their fragments framework. So I knew that a lot of the stuff I'm thinking of doing here can be done directly in the browser without any backend whatsoever. Essentially, if you could run it in a simple HTML and JavaScript and CSS file, that's all the server has to do. We're not going to have to process anything heavy on the back end for now. When I saw that it was talking about all this back end stuff, I'm like, nah, I didn't even continue reading. I just said the front end should proceed to convert the IFC into a fragments model by using that open company's latest fragment engine. This way, the heavy processing is done using the WebAssembly and the user's browser. So then, of course, Gemini obliges and says, excellent idea, and then spits out its next iteration. And maybe I should close this canvas just to explain so far where we're at here. So it says, excellent idea, moving the IFC to fragments conversion, and then it gives me the whole spiel here. So I read this, and then by the time I got around here, it's starting to look pretty good. It seems like kind of what I want to do. But then I noticed that it's still trying to do IDS validation, then do that on the back end. And I also noticed that it's talking about JSON data having the properties of the IFC file exported into JSON. So that was a little bit of a red flag to me. So I said, check the docs. I think the properties can be embedded in the frag file. No need to use JSON. And I fed it the documentation. It went back. I can see that it understood that it's using Google flat buffers, which is the case for that open company. That looks good. And it comes back with its next iteration. I think it's looking good. The only thing that was left here is that what I didn't agree with, I believe, was getting the filtering and BCF capabilities directly in the browser, so we don't have to run that on the back end either. So that's what this ended up being. If we read through this, it's starting to look a lot like an app specification, except for the fact that IDS was still going to try and do that on the back end, so I guided it towards the proper documentation, and then it gave me this final draft. Then what I said is start putting that into a spec, and I activated the canvas, which looks something like this. If we open this up, this is the document that it created. It gives us a basic title, a project goal, which if you read it carefully, does align with what we're trying to do. And if we read the core principles, it kind of makes sense, although I never actually told it to do zero data upload. I guess for now, we're going to be doing all of that directly in the browser. It is going to give us more instantaneous feedback to the user, so that's good. All the heavy computation is going to be done on the client side, which is good because it will cost us nothing for a server and we can make it available to everyone. It's going to use an open source foundation, so that is accurate. Target audience, it just came up with this, and that's probably somewhat useless in our context right now. Let's look at the tech stack in more detail and make sure that what it's giving us here will actually be buildable and make sense. So it's saying that it's going to use some HTML, CSS, JavaScript. That makes sense. It's true that we don't need a lightweight framework, but technically that open components is sort of going to be our framework, at least on the UI side somewhat. We're going to use fragments for the underlying engine. That's good. WebIFC comes into play, so I agree with that. 3D rendering is going to be 3JS, which is what's used by that open component, so that's perfect. And the backend's role is strictly limited to serving the static application files. Totally agree with that so far. That's good. All data processing occurs in a closed loop in the browser. We select a local IFC and an IDS file. We drag and drop it into an interface. So far, so good. So I think based on my current understanding of what the frameworks can do, this seems pretty good. And looking at the end-to-end components of the data flow, we're going to be able to give it an IFC and an IDS. It's going to take the IFC, convert it to a fragments model. Then we're going to use the fragments model to extract data and run filtering and apply an IDS validation to that model. And then we're going to get a BCF report of any issues. So that seems to add up. Now let's scroll down a bit here to the user interface and workflow. It says that we're going to have a toolbar at the top that says load IFC, load IDS, run validation. That makes sense naively. We'll see about that later. On the left panel, it's going to display validation results, issue details, filtering options. Okay. We're going to make a mock-up of this anyways here in a few seconds. Let's read through the step-by-step user workflow. Notice that this might be a little tedious, but it's important to take our time and read through the spec and iterate on the spec at this point in time before we get too far into actually writing code. This is going to save you a lot of time down the road, even though it seems like we're not moving very fast right now. Initial state, the user is greeted with a simple interface prompting them to load an IFC. We click on load or drag and drop the files. Yep. Clear feedback. All right. Yes. Now, I'm noticing that it doesn't have much of a feel to how the app should look. We're just going to add something here. Make sure the app looks aesthetically pleasing. Use modern CSS and HTML. Actually, you know what? I'm going to rephrase that. I'm going to say that open components UI, and let me just go grab that real quick. So what I'm going to do is tell it to use the documentation from that open component UI. That should do the trick. Let's feed that in and see what it does to the spec. Of course, we're going to reread what the spec says once it's done processing. We'll give it a few moments. Here's something that typically happens with these LLM models. It kind of went completely crazy here and started writing code, which is what we want to do eventually, but not yet. So I say, please only update the spec no code at this time. Maybe I should have specified that, but we'll see if it manages to correct its trajectory. Okay, now it is working on the spec, so that's perfect. I don't want it to write any code, so we'll just let it finish processing. All right, so the spec is updated. What's nice about Gemini is that it highlights certain things that just changed. So we want to see this here. For creating the user interface elements, it's going to use that OpenUI. That is what it is called here, so that's perfect. And in the backend architecture, the implementation is going to be Node.js/Express. Looking at this here, what's nice is that Gemini highlighted the differences between the previous and the latest version of this document. And it says that it's going to use that OpenUI for creating the user interface elements. And it also updated the fact that it's going to use Node.js. And it's my mistake, Node.js/Express. It's just saying that it's going to use that technology together to create a server for these assets. And it's saying we could host that somewhere else. That's perfect. 3D viewer, drag and drop overlay will be present to guide users. It added quite a bit of detail, modified some of these things to make it more UI focused or add some UI context. So it looks good. I don't see anything jumping out at me really quick that is broken compared to what we previously had. It added this thing that it wants to color things red if they fail. So that's good. Okay. Core features and implementation logic. Now that we've cleared the basic stuff, what does it say here? It's giving feature IDs, so that's kind of interesting. File loading and state management. Implement on-click handlers for load. Okay. All right, so that seems reasonable. Drag and drop handling is another feature. And the validation engine. All right. Cool. So I took a few minutes here to read through it, which I've edited out to not bore you, and take some time to read it, see if it makes sense to you. If you spot anything that maybe we should have added in here, let me know in the comments. Non-functional requirements, this is useful, but for now, have less of an application since we'll be keeping a close eye on the AI doing this. So one last thing I want to add are clear exclusions of things that we are not going to include in the app at this point. I want to modify the spec to include exclusions, things we won't include in the minimum viable prototype. No authentication, no AI features, no server-side processing, no analytics. So also add that we will use TDD, which is test-driven development, where we write the tests first, have them fail, then, or confirm they fail, I should say. Confirm they fail, then write implementation. All right, let's send that in, have it update the spec. All right, so Gemini has completed updating the spec. We can see here that it's added this MVP exclusions, minimum viable product exclusions, to ensure a focused and achievable scope. No user authentication, we won't have user accounts and all that stuff. No AI features, no server-side processing, and no analytics. Now, the list could go on, but these are some of the basic things that these AI systems tend to overthink. Development methodology. Essentially, what we're doing right now is what has just been coined as of this week, as far as I'm aware, spec-driven development. Of course, using AI, spec-driven development itself is not new, but in the context of AI, we're going to write a spec and then have that implement the code for us. We also want to make sure that the AI itself uses good practice of writing tests, confirming that they fail, then writing the implementation for that test to pass. This might be challenging at times, but we're going to at least have it write a very basic test to, for example, check if the feature even exists in the system. so that if it gets removed or heavily modified in the future and starts to break, we can confirm that really quickly by writing our tests. All right, so I think our specification, at least the high level one, is detailed enough at this point. So what I'm going to ask the AI to do, we're going to say, please create a one-page HTML mockup, use CSS and JavaScript if needed, of what the UI would look like based on this spec. And what we're trying to get it to do here is we don't want it to start writing a bunch of code. We just want a simple sample. It's only a sample, not the complete implementation. I'm going to add that because with Claude, it tends to not go off and do crazy stuff too much, but I find with Gemini, it tends to overthink things and take the initiative when you don't want it to. So let's see what it comes up here now. Starting to spit out some HTML code, and as soon as this is done, we're going to be able to preview it. And then based off of this mockup, we're going to comment on it and then have the AI update our specifications with any details we may have picked up on. This is a really interesting flow I've used on other apps and has very good results for the prototyping phase. All right, so this is the first pass that the AI took at creating this. Not bad, right? But let's add some details. So for one, I want it to use styling and colors from my website. I'll give it the website opening BIM. We load IFC, looks good. This IDS schema loaded thing is a little clunky, but overall it's okay. If we run the validation, it doesn't do anything. When I click on run validation, please show me the left-hand results as derived in the spec. Now we'll have it think a little bit more and rewrite its code. The code is finished. Let's see what it looks like. Preview. This already looks a little bit better. Load IDS, run validation. That's pretty cool. I like how it faked these results. I love it. Export BCF, of course, doesn't do anything. Okay, this is looking much better. And it seems to have picked up somewhat the colors from my website a little bit more. So I'm good with this. This is just a mock-up, right? This is just to start getting our head in the right place as to what this is going to look like. Very low effort, very low friction. We already have a mock-up done. Okay. So what's the next step? The next step is to actually take this one step further along the spec-driven development process. Right now, we have a very high-level spec. We have a mock-up. And what we should do now is ask the AI to integrate any things discovered based on this mock-up iteration back into the spec. Please integrate any details learned from the mock-up process back into the spec. Let's do that. So let's have it spin up here. It should start thinking about the spec. So it's labeling it as version 1.3. I did add this here, main view layout and visual design. So it picked up on the color palette. Typography. Yeah, that's pretty good because we don't want it to add too much detail right now into this process. This video is starting to get a little bit long. I'm going to wrap it up here for this episode. What we're going to do in the next episode is take this mock-up, take this spec, and start to create more detailed design documents and more detailed task documents to get down to the nitty-gritty before we even start coding. I promise you, by the time we get to coding this thing, we're going to see some amazing results. It's all about context. Catch you in the next one.